For our objectives, first, we'll be able to solve basic clock problems, and we'll able to know different methods in solving clock problems later on. And yes, the importance of this problem or topic is that first, it's a necessity for us as an engineering student to know, and even non-engineering student, the time or clock problems, because time is gold and gold is money. And second, this type of problems are problems that are in examinations and also in quiz bees. Okay, for the topics that we'll be discussing, first we're going to discuss about how to convert DMS or the degrees, minutes, seconds to degrees, which is the angle, and vice versa. So from degrees to DMS. And the second one is we're gonna be learning clock aptitude reasoning, which involves solving problems or solving worded problems. So our first lesson is that we're gonna convert degrees, minutes, seconds, or DMS to degrees. So we're going to assume that 1 hour is 1 degrees, and as we all know that 1 hour is 60 minutes, and then it's equivalent to 3,600 seconds. So for our first example, we're going to convert 45 degrees, 28 minutes, and 32 seconds into degrees. So what we're gonna do is we're going to copy the 45 degrees and then add the 28 minutes, and then we're going to divide it by 60, since we all know that in 1 hour there is 60 minutes, and we're going to add the 32 and divide it by 3,600, as 1 hour is 3,600 seconds. So we're going to calculate it. We can come up with the answer, which is 45.4756 degrees. Alright, I think we're done with the DMS degrees. So let's do the reverse of it, which is from degrees to DMS. So let's try example number 1. Convert 38.4256 degrees to DMS. So step number 1, we're going to get the whole number, which is 238. So for 38.4256, we're going to get this line out. So what's left is 0.4256. So 0.4256, we're going to multiply it by 60, since there are 60 minutes and 1 hour. So this is an hour. So we can get 25.536 minutes. So you already get the value for your minute. So it's like what you've done for the whole number in degrees. So you get 25 here, and what's remaining is 0.536 minutes, and then multiply it by 60 seconds, for there are 60 seconds in 1 minute. So the answer for this is 32.16. So you have already got degrees, the minutes, and the seconds. For your final answer, you're going to write it like this. So 38 degrees, 25 minutes, and 32 seconds. Let's try example number 2. Convert 62.3175 degrees to DMS. just same just like what we've done previously. So get the whole number for degrees, then what's remaining here is 0.3175. So 15 hours times 60 minutes in 1 hour, and then we could get 19.05 minutes, and then get the whole number for minutes. So what's remaining is 0.05, and then multiply it by 60 seconds, and 1 minute, equivalent to 3 seconds. Final answer here is 52 degrees times in minutes. That's the final answer. And yes, just like what we've done in the calculator technique previously, we can also convert degrees to BMS using a calculator. So we're going to input here, if for example it's 52.3175, and then enter, and then shift the symbol for degrees, minutes, and seconds, and then there you go. It's 52 degrees, 19 minutes, and 3 minutes. So I think we're done with the first topic, BMS degrees and vice versa. So we're going to proceed to our next lesson, which is about clock aptitude reasoning. So this clock aptitude reasoning, which involves worded problems that involves clock. So let's take example number 1. The time on an analog clock reads 12:30. So the question is, what is the angle between the minute hand and the hour hand? So the solution for that problem is that first we need to draw it so that we'll be able to visualize the minute hand, or the position of our minute hand in our hour hand. So it says here it's 12:30. So 12:30, so 12, 3, 6, and 9. So 12:30. So 30, meaning we are at the number 6. The minute hand is in number 6, which is 30 minutes, and then 12, it's between 12 and 1. So it's in the middle of 12 and 1 since it's 30. So after drawing it, we can come up with the idea that 12 hour is one complete revolution of a circle, and one complete revolution of a circle is 360 degrees. So we can say that in 1 hour there is 30 degrees. From this time, from 1 to 6, we have 5 hours. And in 1 hour, we have 30 degrees, have 150 degrees for 5 hours. And between 12 and 1, since we said that it's in the middle of it, so we can say the 0.5 or 1/2 of 30 degrees, which is 15 degrees. And we're going to add 150 degrees and 15 degrees. And the answer is 165 degrees. So that is the angle between the minute hand and the hour hand. at time 12:30. Try to solve another example. For example, number 2. Convert the time 1 hour and 20 minutes to degrees. First things first is we're going to draw it with time 120, 12, 3, 6, and 9. So 20 minutes. So it's number 4. The minute hand is 4. And the hour hand is between 1 and 2. Not necessarily in the middle, but between 1 and 2. This is the hour. The question says here that we're going to get the angle between this number between 1 and 4, between this and this. So for the solution, one technique to solve this is first we're going to get the minute. So we have 20 minutes here, and we have said earlier that in 1 hour there are 60 minutes. So it's 1/3. It's 1/3 far away or away from 1. So if it's 1/3 away from 1, so meaning it's 2/3 away from 2. So from this given, we could be able to solve already the angle between it. 2/3, and in 1 hour there is a 30 degrees, and then plus 30 degrees for 2 to 3, and then plus 30 degrees from 3 to 4. So the total for this degree. For this last question, there are steps here involved so that you can be able to solve it comprehensively. Let's try this one out. So example number 4. What time after 3 o'clock will the moon and the hour hand of the clock be A together for the first time? Alright, for the solution, we have proposed 3 steps here. So first step, so we're going to count the number of minutes from the start time, which is 12, to the desired time without moving the hour hands. Do not move hour hand. So that's the first rule, do not move the hour hand. And then you just need to count the number of minutes from the start time, which is 12. Our problem a while ago says that what time after 3 o'clock will the minute and the hour hand of the clock be together for the first time. So this one, they should be together for the first time. So we do not move the hour hand, so it stays here in number 3. And the minute hand is number 3 also. So we're going to count here. So since it's 3, and we all know that per number there is 5 minutes in it, so we're going to multiply it by 5 and then result for 15 minutes. So that's the value of our t. So for step number 2, we're going to multiply t times 12 over 11. 12 over 11, this is the factor that the correct movement from the hour hand. So our answer while ago for t is 15 minutes. 15 times 12 over 11, 15.3636. And for step number 3, which is the last step, we're going to remove or store our minute, the whole number of the minute, which is 16, and then multiply the remaining, which is the 0.3636 times 60, since there is 60 seconds in 1 minute. So the answer to this is 21.82 seconds. So here we go. So we have already solved the problem using 3 steps. So the final answer is 3 hours, 60 minutes, 21.6 seconds. That's the time in our minute hand and our hour hand are together for the first time. So for letter B, perpendicular, the minute hand and the hour hand after 3 o'clock are in perpendicular for the first time. So we're going to draw it again, and I would really advise you to draw it so that it would be easy for you to solve it. So it says here, perpendicular. So when we hear the word perpendicular, what comes to our mind is that it should be 90 degrees with each other. So 3 o'clock, this is our hour hand, and it should be here between 7 and 6. Or for you to be able to know if it's perpendicular, so we're going to count 30 degrees per hour. So this is 30, 30, 30, this is 90. So it's after 6. Since we're done with visualizing it, so we're going to solve the T. Our minute hand is in number 6. So here, we should be able to make this hour hand and 3, and then this minute hand and 6 if we're not going to move our hour hand significantly. Right? And 6 times 5, which is, we have 5 minutes in every number, and this results to 30 minutes. And then multiply this one to 12 over 11, which is the factor that we have come up a while ago for the step number 2, 32.73. And then lastly, we're going to remove or store the minute 32 and then multiply the remaining 0.73 by 60, as we have 60 seconds in 1 minute. And then the answer for this is 43.8 seconds. We're gonna write the time, which is 3 o'clock, 2 minutes, or 3 hours, 32 minutes, and 43.8 seconds. So this is the time by which our minute hand and our hour hand are perpendicular for the first time after 3 o'clock. Okay, for our last example here, the time after 3 o'clock by which our minute and our hour hand forms a straight line for the first time. So again, draw this. So after 3, this is our hour hand, and then this is our minute. It should be longer compared to our hour hand. And if we're going to remain this hour hand still, so we could say that our minute hand is the number 9. So number 9, or 9 times 5, that's 45 minutes. So 45 times 12 over 11 is equivalent to 49.09. And then lastly, store 49 and then multiply 0.09 minutes times 60 seconds per minute. And it's 5.4 seconds. So it's just pretty easy to solve this one as long as you're able to know the concept behind it and also the technique in solving. So the final answer for this is 3 hours, 49 minutes, and 5.4 seconds. So this is the time by which our minute and our hour hand form a straight line for the first one. So here's the problem that I want you to solve in your own, and there is an answer already so that you'll be able to check if you have done it correctly. Yes, that's all for today, and I really thank you for listening to this video, and hopefully you'll be able to answer future problems involving clock. And don't forget to watch the other videos here in our website. Thank you.